flat, right? It looks flat.
Yeah, as we'd expect a giant ball to look flat.
But again, that's you jumping
surface,
now
right?
into presupposition.
No, it's not a presupposition at all. It's a prediction that we can make with something that size. We can predict that that's what it would look like, even if it was that size.
Based on
not
what?
A presupposition, it's a prediction.
What's it based on?
Shut the fuck up.
What's it based on there, Paul?
What?
Curse with IQ, sorry. What's it based on?
What's what based on?
That it would look like that on a board. How do you know?
Well, because we have measurements of being in this size, don't we? And if are you presupposing that it's flat?
No, I'm saying it looks flat. That's what we observe.
Yeah, sure, but that's not a discriminating factor to know an answer to something, is it?
Yeah, but you're saying it's not flat.
Sure, there are other reasons why it's not flat, but saying that it looks flat isn't enough to discriminate what shape it actually is, though, is it?
Yeah, but you would start there.
Because there are lots of things that we would expect to look flat but not be flat, right?
Yeah, but you would start there, and if there's any more information to say that it's not...
Are you presupposing that because it looks flat, it must be flat?
No, what I'm looking at is not a presupposition.
Yes, it is. You're saying that because it looks flat, it can't be anything else other than flat. That's a presupposition. You're presupposing that there's nothing else that could possibly look flat.
Yeah, I'm not doing science here. I'm just looking at the horizon.
I know you're not doing science, and that's the whole point. You're just not doing science.
Yeah, that's
right.
right. It's just
so you've got no reason to make any claim here.
I'm glad
so
we agree.
you're literally presupposing that the only reason it could look flat is because it is flat, and yet you're making the presupposition that there's no other situation where it could look flat but not actually be flat.
Anyway, we agree that it looks flat, right? That's what we agree on.
Yeah, sure, it looks flat, but like we've said, that's no reason to believe that it is flat.
So welcome to Flat Earth, because you don't have any more information to go beyond.
Not welcome to Flat Earth. That's welcome to
it looks
flat. Therefore, that's not a good enough reason for us to know what shape it actually is, because it just looks flat. Because you're making the incorrect presupposition that only something flat can look flat. But that's not true, is it, Chemo? Your logic fails you.
Give an example then of something that's not flat, but not curved. Or that is curved but looks flat.
Twisted now, aren't you?
Right.
You really have no idea what you're saying. Right, you're befuddled, you're flabbergasted, you're fighting to make sense, right? You know that just because something looks flat doesn't mean that it is flat. Because are you honest enough to admit that there are things that could look flat but might not be flat?
No, like what?
Come on, no. So you're not honest enough to admit that there may be some things that could look flat but not actually be flat.
Like what? A basketball zoomed in?
Asking you, are you honest enough to admit that there could be some things that might look flat but not be flat?
I just said like a basketball zoomed in.
After investigation.
So you're not actually going to answer the question.
I don't know what you mean.
No, literally what you're doing is presupposing that the only thing that can look flat is a flat Earth, right? So by saying or by not answering the question, are you honest enough to admit that there could be things that look flat but are not flat, right? You're denying a possibility that might exist.
No. Saying,
Yeah, it seems to be beyond your capabilities of imagination to imagine something that could not be flat but might look flat from a certain perspective, right?
Saying we observe flat. So we have no other reason to think that what we're looking at is not flat.
No, we have no reason to believe that it is flat just because it looks flat. Because my imagination is good enough to imagine situations where something might not be flat, but it might look flat. And so taking into account those possibilities, then saying that it looks flat or
How long?
observing that it looks flat is not enough to distinguish that it is flat.
Mm-hmm. Hey, Flat Earth Fire.
Hello.
What did you think of what we've just said?
It's good.
So, Paul, I mean, again, we see flat, yes? So we have no
but that, of course, if you're honest about it, is not a good enough reason to presuppose that it is flat. Because, like I've said, I can imagine, at least I've got the ability to imagine, things that might not be flat, but might look flat from a certain perspective, right?
You're not thinking, Paul. You're not thinking.
And because I'm honest enough to know that there are possibilities where something might look flat, even though it's not flat from a certain perspective, then I know that I can't use the observation of it looks flat to distinguish that it actually is flat.
No, we're not saying that. We're going with what we observe until we have more information, right?
Why don't we talk about what we observe? Why don't we talk about what we can observe in the total sense of what we can observe? We can observe more than just it looks flat. There are plenty of other things we can observe, can't we? So why don't you talk about one of those other things we can observe, like the stellar rotation around the South Celestial Pole, or the 24 hours of sunlight in the Antarctic regions?
I would have said high altitude.
Why not?
I would have said high altitude balloons. More of the Earth. More flat.
Of course. But then again, that's what we would expect to see on a globe anyway. So how does that distinguish flat from globe? It doesn't, does it? Unless you're honest enough to know that from an altitude we can actually measure the curvature. Then that discounts the flat Earth, right? But you're not honest. But you're not honest enough to admit that evidence because you're just not honest.
I have a question, Chemo. What's the shape of our eyes, Chemo? What's the shape of our eyes?
An eyeball.
So what's the shape of it? Like, what is it?
Ball. Eyeball.
Is it flat or is it curved?
Why is it a ball?
Eyeball.
So how do you know our eyes are not affecting the shape of the Earth?
Oh my gosh. An eyeball.
It's curved, isn't it? Our eyes are curved. So how do you know it's not fixing the curve of the Earth with their
because of
shape of our eyes?
Science.
What science?
You don't deserve an eyeball.
If we see like a fountain, like water curving over that fountain, and you say,
but how do you know our eyes not affecting what we see? Since our eyeball's curved, how do you know it's not being affected by our eyeball shape?
Focus, dude.
What does that have to do with anything? How do you know for sure?
We stop things from being distorted. Focus. What the camera does, like our eyes. Focus.
Well,
so
you guys then you can't. All right. Chemo, then you guys can't complain about the fisheye lens. Then you can't.
Fisheye lens is not focus, dude.
No, it's still focus. If focus is
really?
on
You're bendy, or it's why it's called a fisheye lens, dude. Because the fisheyes have got a different focus to what we have. You dig?
Yeah, but you're not explaining. You're not really answering the question. You're just dodging.
That's what the shape of the eye is. I told you it's a ball, like a ball, eyeball.
And I'm asking you, how do you know it doesn't affect what we see?
How does that affect? Because I've just told you, focus.
Do you have evidence of this focus?
Now you're just being silly.
No, not really.
Never seen a camera focus when it's all blurred? Can you make your eyes go blurry? You have that ability.
What does the focus have to do with the shape?
Because when it's blurry, you don't know what shape it is, right?
Yeah, but the light's still bending in your eyes.
Yeah, but the eyes are all blurry. Like, what's going on there? Like, sometimes, if you're really drunk, you might see two things. Then your eyes are super unfocused. Yeah?
Yeah, but that doesn't determine the shape. It's just blurry.
Yeah, well, again, if those things are distorted...
Do you know the difference between shape and blurriness or focus?
No, distortion. Just like the crane, like the bendy...
Do you know the difference?
Like the bendy crane, what shape was that bendy crane?
I don't know.
Ah, exactly.
What Bendy
Because it
Crane?
was
I don't see a picture
distorted.
of Bendy Crane.
That's my point, Pyro.
You keep dodging, man.
No, but the
How do you-
bendy crane,
you enjoy
people
dodging?
always say, the bendy crane's not bendy like that, is it? So that's not the right shape. It's not in focus.
Yeah,
Shit.
it's called refraction. Yeah, refraction.
Distortion, out of focus, yes. All those things. See,
So how do
Pyro?
you know your eyes is focused to see the proper shape of things?
We can measure stuff.
Measure.
And we can check for 20/20 vision. We have doctors, opticians.
But 2020 is.
No, but we have
Yeah, you can see 20/20, but it still could be
opticians can check
bendy.
the eye. They check the eye, opticians, and they can tell you if you need extra eyes, like a lens. No, because if your lens is not correct and not focused,
You do know when people wear glasses, it does bend things out of shape even more.
that's what. Oh my goodness, you're arguing your own argument here. Out of shape, yes, out of shape. You don't know what shape it is.
But how do you know things are completely flat?
Because I've been to the optish. Yeah, the optish says you got good eye. Yeah, go for test, Pyro. You know, you read that chart.
Yeah,
and stuff.
just because you can see clearly doesn't mean it's
What?
straight or stuff.
Well, I don't know. That's just what the op says. The optish. The optish is like, you've got good eyes. You don't need any extra eyes. Yeah.
So why then, Chemo, when I go to the optician and get a new pair of glasses after I haven't had glasses for a while, and I put those new glasses on, I can read everything clearly, but all the corners of the room look fucking bent and out of shape. Why is that?
Oh, that's just the lens effect.
But why?
The lens bent.
I mean, aren't they supposed to correct my vision and make everything perfectly right?
Oh,
No?
you got to get used to double stuff.
Oh, you got to get used to them. Why?
Yeah, you got to wear them in. You know.
Ah,
the
so
brain,
so
like, for example,
somehow my vision changes over time.
Yes.
Does it?
Let me explain.
So can we believe anything we see then if it changes over time?
No. The brain.
So I look at the same thing on separate days and it looks different, then how can we ever use our eyes to ever determine the shape of anything? I don't trust my eyes anymore, Chemo, because they just obviously don't see anything accurately.
Good.
Yeah, and if the atmosphere acts like a lens, then anything can happen. You just get used to it.
Not if you've got good eyes, then you.
Yeah, we just need to let the atmosphere settle in, right? So once we've let it settle in for a period of time, then we can trust it, right? Because we can trust glasses apparently after we wear them in for a certain period of time, right?
You gotta wear in the atmosphere.
I
Yeah,
thought I
yeah.
had good eyesight until I went for an eye test, and then I needed 2 pairs of glasses. So there you go.
And then after you're used to those, Tao, you'll need 3 pairs of glasses, right?
Fucking will, yeah, 'cause I need a bifocal pair next, yeah.
Okey dokey. So, the idea is, as Pyro's just said, things are bent out of shape. Like, I was looking for that word.
We have to just so we have to throw out all evidence from our eyes because we can't trust our eyes anymore, right? Because they're lenses and they bend the shape of things, you know, they change what we see. So we can't use our eyesight to determine the shape of the earth, right?
Not only that, but Kimo said that the horizon is apparent and not physical, so we can't make up a shape looking at the horizon.
No. You've got it all wrong. Completely backward, upside down, inside out. So the idea is that if you go to the optician,
Well, if it's upside down, then I'm in the right place to make sense of it because after all, I'm in Australia.
yeah, that just means you're across the road, not upside down.
Oh, so we're not upside down.
No, you're
So are
over,
we upside down or are we not upside down in Australia?
There wouldn't be a bloody direction if it
just
wasn't
over
for
the
the
road.
horizon.
You're over the water, over the river.
If you had no horizon, which
You're a
way up
stone's
would you
throw.
be?
Or just over the waters there.
So am I
Kimo?
looking up at the horizon, Chemo? Because I'm in Australia?
The horizon for you, Bob and Alice tells you you're looking down. Both
But if
looking
I'm upside down, I must be looking up at the horizon, not down at it.
No, that was the old idea that you were upside down, down under. No? You're not down under anymore. Now we know it's not a ball. Yeah, you're across the road. Or
Oh, you
across
mean
the
you're
street.
presupposing that it's not a ball?
How can you
Yeah.
presuppose it's not a ball? You don't observe a ball.
Well, because you haven't measured it and we can't observe it. We can't use any measurements from our eyes because we can't trust our eyes. So you must literally have to presuppose it's not a ball.
No one's measured a ball. No one's measured curvature, Paul. No one's seen the ball.
Well, if no one's measured it, then how do you know it's flat?
Yeah.
That's what we observe.
We don't.
Like I've already said, that what we observe really doesn't distinguish what the shape of it is from that perspective, does it? Because I can, like I already mentioned before, can imagine heaps of different shapes where it would still look flat from a certain perspective.
Yeah, but we've been to the highest altitudes we can possibly go, and it's still flat.
No, it's not. That's just where you're lying.
No, even from the International Space Station, they say it's flat.
No, see, this is the point. This is the point where you have to actually lie to support your
Who's lying?
argument, because that's
lie?
just not what we observe, though, is it?
What's the lie?
Chemo? Is that we observe it as flat when we just don't. And to support your argument in that sense, you have to reject any evidence that I present to you, which you're going to do by just saying, no, that's fake, that's CGI. No, we haven't been there, so how can we take that photo? You just have to lie about the evidence.
First of all, we have experts who agree with what we say.
What experts?
Yeah, I mean, we also have experts, Chemo, and those experts say that the Earth is a globe. Go figure. So if you're going to appeal to authority and say that you have experts, then, hey, man, I have experts too.
I can't take this shit anymore.
I know.
What's the problem
Then leave.
Flat Earth Fire?
Nothing.
Speak your mind, speak your mind.
Yeah, come on, White Knight for Chemo. He's struggling, man.
Oh,
Give him a bit of
no, I'm
support.
about to take you down, but obviously I want to share the mic and whatnot.
In your dreams. You didn't want to share the mic. Fat bastard.
Jesus.
Okay.
Yeah, if the Earth was flat, I could accept it if I could see the sun everywhere, every time.
Well, look, either the model works, and it means
Right.
you can't see curvature from that height, or the model is broken and you can see curvature from the ISS.
Have you tested the model to see how much curvature you would see at the ISS?
Yeah, you've got the
Other alternative, well, there's the other alternative, Chemo, that the model could be right, and we can see curvature from that height, which is what happens, right?
No, because from the ISS you can't see curvature.
Have
But
you
we can,
tested?
but we
have you
can, and you
tested
just
the
have to
model?
lie about it.
Yeah, we've got the solarium or the stellarium or the planetarium, and they
Okay,
show
have you? How much curvature did it show at the height of the ISS?
none. It's flat.
Can you show it? Can you show it? Okay, please post it.
Go to my channel. Under
No, post it.
Under no pressure.
And
Seen
what
it many
video?
times before. It's all there.
Oh, I haven't seen you test the model.
Yes, you have. It's all under no pressure.
No, I haven't.
No, no, we've got two experts, Neil deGrasse, and I forget the name of the other. There in the planet.
That's not testing the model though.
Of course it is.
Oh, I've got 10 experts, Chemo. My 10
How
experts
do you
trump
know
your
I
2
didn't go
experts.
to that convention there and was learning that mole, man?
Yeah, you didn't test the model.
Yeah, but if I go to where an educator is and he's teaching that, now what? With his
Yeah,
model.
you still didn't test the model.
And a
You
model
didn't
that he
test the model.
says you can come up after the show and interact with.
Okay, show me the evidence that you did it.
No, but I'm saying,
Please post
what difference would it make?
that. Then you tested the model.
And then what? You become a flat earther.
No, then you can see if you'd see curvature at the ISS or not.
Does that make you a flat earther?
Well, no, it'll just show that if the model is correct, how much curvature you would see.
Point. So you need to get the model and show that you can see.
No, but you claimed that you can't see.
Not me, the physicist.
No, you said it. You said that the model says that there's no
That's
curvature
what
at
the
the ISS.
physicist was teaching. Astrophysicist.
He said that.
Astrophysicist, yeah. Yeah.
Sure. So did you test his claim?
Well, yes, you can get a model. You can get a Google Earth.
Yes, and that's why I asked, did you test it?
On Google Earth, the same thing.
Google Earth, the same thing.
Earth, isn't it?
Sure. So I can go to
You just
Google
draw
Earth now.
circles around like how much you can. Can't see curvature from the ISS according to the expert.
So not according to the model, but according to an expert.
Who's using a model?
Did he use the model to make the claim?
Did he use a model?
Yeah.
Model. Use a planetarium, stellarium, solarium thing.
What's a planetarium, stellarium,
Planetarium,
solarium?
stellarium, solarium. So these are real life, well, real to scale size of where we
You
live.
know you're full of shit when you're talking.
No, it's on my channel, I told you.
Yeah,
Scaled
and I
down
asked
model
what
of
video.
the Earth, of distances to other celestial bodies and stars and stuff like that, right? So either the educators are lying, or you are just finding it hard to accept that they've got the figures, the facts, and the numbers, and they hand them over to us, and we pass them on, right?
Or then they're just using their words colloquially, like saying that stuff is flat when there is just a little bit of curvature.
Little bit.
Yes, a little bit of curvature.
A little bit.
Yes. Do you know what that means?
As opposed to a lot.
Yes.
What is a lot of curvature and a little bit?
I don't know. If I say I'm full when I've eaten, I don't mean that I'm physically full of food, like my feet, my stomach, my hands are full of food.
You're spiritually full.
Fuck off.
What do you mean then? But look, a little
We're
bit.
stuck.
You're saying a little bit. So what height can we see a lot of curvature?
That's why I said, have you tested the model?
Talking about in reality.
Yes. In reality.
Yeah.
You can check the model and see at what altitude you would see the curvature.
You don't know.
Obviously, you haven't done it.
Are you a globe
So you
earther
can't
who
make
does
any
not
claims
know this
about it.
answer?
Yeah, because I don't give a fuck about the answer.
Okay, fine. So you're a globe earther who doesn't know the answer to how high we can see a lot of curvature.
Yep, I don't.
Okay, that's fine. No big deal.
Yep.
Yep, fine.
Who else? Who else?
Oh, okay. Does anyone else know the height you have to go to see a lot of curvature?
Calling out all globies.
How high do I have to go to see Australia if I'm above Finland on the planet?
Well, you can from the ISS can see around 2,000 kilometers.
I should be.
So you
I should be able to
Can you
see.
it's more than 2,000 kilometers away, right?
Yes.
Oh, you're not gonna see it. It'll be too small.
Why would I be able to see 2,000 kilometers at the height of the ISS on a planet?
Why?
Yeah. Why can't I see 2,500 miles?
We're stuck. We ain't
You
moving.
possibly could, depending on the atmosphere. Depends on which country you're looking over, like their seasons, the weather, all these factors. Like if there's a lightning storm, you're not going to see very far. But if it's a nice summer's day, again, you might not see that far. It might be. So again, it just depends if you get a nice mixture of clear weather, cool. I mean, it's hard to say, but again, yeah, you could see as far as you like, even standing on the Earth, if the weather was favourable. It's got to be favourable.
Oh, can I see, say, 80 kilometers away?
If there's no obstruction, yeah, sure, why not?
Yeah, because I've been in Helsinki and I didn't see Tallinn, which is like 80 kilometers away. There's water.
What time of day did you go there? How long were you there for?
I've been there many days looking at the sea and I didn't see the city.
You camped there for like several days?
No, many times when I go to Helsinki, I just look at the sea and I don't see.
Oh yeah, weather-wise, weather kicks. You know, it's not favourable because when we went out to St. Bees to get observations, you know, sometimes weather was not favourable, so we had to take a rain check for that moment, come back later or the next day, early morning. You've got to like be lucky really to get that favourable atmosphere moment. Okay?
Yeah, sure.
But you could see as far as the eye. Miles.
Yeah, so
upon
if I go
miles.
to top of Mount Everest, I can just zoom in with
As
a
long as there's no
telescope to
obstruction,
America.
long as there's no mountains in the way or anything. You know, you can see
Oh, water. Yeah.
water. Oh, you can see
A curvature, yeah.
No, don't be silly. Curvature will never give you obstruction on the Earth. Remember the horizon. That horizon. Remember, every horizon, the Earth doesn't drop beyond that. Nothing will disappear bottom first beyond that horizon in reality, right?
Why?
Because it's apparent. So let's say, for example, you went out to Helsinki, like you said, or somewhere, and then you saw a boat disappear 3 miles away, bottom
Bottom up,
first.
like we do see. Yeah.
You could go the next day, that boat disappears 10 miles away.
Why does it disappear bottom up? Because the bottom is bigger than the top.
Oh, that's because the ground ramps up.
The ground ramps up.
Mm.
So water is bending up.
Yeah, you could kind of see it. It's kind of converging like a railway track.
So,
you know?
so it's a concave.
It's not really bending up there. Not really doing it.
Okay, but wouldn't the boat also bend up?
No, because the boat is in the atmosphere, it will go down.
But the water is also in the atmosphere.
What?
The water is also touching the atmosphere, right?
No, the water is the surface, the ground. Yeah.
No, it's water.
Yeah, which is on the surface. That's the surface.
Yeah, and the boat is on the surface. Yeah.
No, the boat is now in the atmosphere.
So it's physically lifted off the water.
Well, what do you mean? The part of the boat that you see that's not sitting in the water, yeah, will start to go down. That's with the sky.
What?
So the part of the boat that's in the air, just as with the sky converging down and the ground going up, boat goes down with the sky. Like the sun.
I mean, why doesn't the ground go down too?
No, the ground rises up.
Okay, and the bottom of the boat is below me, and it's ramping up and up and up and up, never down.
The bottom of
So why is it behind water?
No, the bottom half that is obstructed is going down because the sky is going down.
No, but the whole boat is below me. It
Whole
should ramp
boat.
up, right?
I don't get what you mean. The boat is not in the sky, but it's in the atmosphere, right? It's in the air. Yeah?
No,
That
it's in
is
the water.
subject, anytime that boat is in the air, it's subject to be pulled down or converge as the ground rises up.
Towards what?
The horizon.
The horizon. What is the cause for that horizon then?
Oh my gosh, Marmo. The surface and the sky converging.
Converge. Where?
At the horizon!
No, but you're saying the horizon is the convergence of the ground and the sky, and the position of that convergence is the horizon.
So look, it's just an apparent convergence. It's not actually convergent, moment, right? Get that out of your mind. It's not actually happening. It just appears that the ground is rising, but it's actually not. Sky appears to be lowering, but it's actually not. See?
Okay. I'm just wondering why is it due? Because if I gain elevation, the horizon moves, right?
That's because the ground is rising as you go up.
So is the sky a physical thing, is it, Kimo?
Yeah.
Sky?
Yeah, where's the sky? What location is the sky?
Is it physical?
Yeah, where's the sky?
A very tricky question, that one.
Well, then how can it be lowering if you don't know where it is? Come on, you said it lowers. You said the sky appears to be lowering. Where's the sky?
Yeah, you think sky is now here. We're in the sky now, on the ground. Right?
You think the sky is a physical thing. You said it can be lowered. You said the
physical.
sky appears to meet the horizon. Well, what's the sky? Where is the sky?
It's a tricky
Yeah,
question
you said
because
how can you ascribe something being lower if it's not a physical thing?
No, I mean, again,
Yeah.
it's
It's a difficult ad hoc for you.
no, it's just
You're just referring to the sky as if it's some meaningful thing that's an object that can be lowered. But what does it mean to lower the sky? I mean, where is the sky?
so the sky, obviously.
No, I'm not God. I'm just Paul.
Blasphemy. That should have said gosh. Sorry, Father. Okay, gosh. Look, not difficult concept. The ground.
Well, apparently it is a difficult concept for you because you seem to be
You
having
can't
trouble. You seem to be having trouble identifying where the sky is.
Yeah.
No. Sky is just the sky. I mean, what are you talking about? It's just
Not
the
having
atmosphere.
difficulty, then where is the sky? And how can I measure the height of the sky? What height is the sky?
Right, this is silly now. We don't
Yeah,
mean,
you've been silly all along, Kima. You've been silly for years. So why change now?
the
So
sky,
tell me,
the
how do you measure
sky,
the height of the sky?
the sky is everywhere, right? So you're in the atmosphere. Yeah, if you were to dig a really deep hole underneath you now and then hover over a balloon over that hole, you would be in the sky. Right?
What?
Dig?
But at what height am I in the sky? I mean,
Just said,
where's-
if you were to dig a really deep hole underneath your feet now and then just attach some balloons and hover over that hole, and the people at the bottom of that hole would look up and see you in the sky, right? Even though you're at
So
ground
how
level.
high is the sky? So how high is the sky then?
How high does the sky go to, you mean?
No, how high is the sky? You
How
said the
high
sky
is
appears to get lower. That implies that the sky is at a particular height. So how does the
Right.
sky get lower? What is the height of
What
the
we
sky?
mean by sky is what is above your head. Yeah, above you.
So
Right.
regardless of whether it's on a flat plane or a globe, the sky is going to meet the ground anyway because that's just what the sky does, right?
Isn't the sky
no.
actually
So
below me too?
so your claim that the sky appears to get lower is a meaningless nonsense claim because how can we ascribe any height to the sky and therefore how can we say that it gets lower if the height of the sky has no meaning?
Like, for example, a cloud is in the sky, right? So that cloud would appear to get lower.
Yeah, but a cloud is a physical thing though, and we can actually calculate or know the height of a cloud, but what about the height of the sky?
Well,
It's
that's it.
First pie in the sky argument.
It's not
Good
the
on you,
same
Spurs.
thing there. You've got like
Kimo.
the
Yeah, you're
cloud.
right. They're not the
Airplane
same
fly
thing.
in
They're
the
not the
sky.
same thing. So why are you pretending that a cloud in the sky is the same as the sky? I still want to hear from you how high the sky is.
Well, I mean, it doesn't really have a height.
Well, then how can you say it gets lower?
It appears.
If I'm on a mountain and I see an airplane flying below my altitude, is that airplane flying in the sky or in the ground?
In the sky, right?
So the sky can be below me too when I see a horizon.
It appears to be, right? But,
Well, it has to be there because the airplane is there.
no, it appears to be lower than you, the airplane, but it's actually higher than you, right?
How can the airplane be higher and lower than me at the same time?
Because the appearance is that it's lower, but it actually is higher.
So if I'm in a mountaintop and I'm looking at an airplane that is below me, actually below me,
Oh, actually
it
below you.
isn't actually. Yeah.
Oh, if it's actually below you, then it's actually below you.
So the sky is below me too.
But, well, no, that's just no. Sky's not below you, no.
No. Okay, so where is the airplane flying then?
The air.
So it's not in the sky, but it's in the air. So everything above, like, the sky is a subjective thing. Like if I go on top of Mount Everest, then people like below me don't have sky above them until
The sky
my
is
position.
always up.
The sky is always up. So if
Is
I'm in
it?
an airplane,
Yeah.
there's no sky below me, just above me.
In the air.
Yeah. So
How do you get above the
So-
sky?
Sorry?
yeah.
What? How are you going to be above the sky?
How'd you get above the sky?
Outside
don't.
the dome. How do you do that?
There is. No
I'm
dome,
asking
but-
you. You claim there's a dome.
Yeah, how are you going to get outside? You just asked how you're going to get out above the sky. That's how.
Yeah, how do you do it?
Rocket.
So now Sky starts, like there's people, like just Kimo just said, the ISS exists and there's people over there. So they are not in the sky because, I mean, the sky has to be above them. So anything below the altitude of ISS isn't sky. So airplanes are actually not in the sky, nor are the clouds.
Yeah, because it depends. Got the air or the sky.
Yeah, and everything below the highest human being is not the sky because the sky can't be below anyone, right?
So if he's in like Felix Baumgartner had air below him, not sky.
Okay, so if I'm at the ground looking at Felix Baumgartner, I can't say he's in the sky because, I mean, that can't be the sky because he's just in air.
Well, you're looking up.
Yeah, but to him, it's not sky.
No.
Okay.
Is
so
that you're doing your
he's
warm-up
not in the sky.
exercises in that GIF there, Spurs?
So you look up at the sky, and he looks down at air.
Sure. So how do I know that he's in the sky? Because he'd just say, no, I'm in the air. The sky is above me.
But I look up.
So everyone who's looking up has sky above them.
Depends on where you are.
Okay, so not always. What is the sky then?
Like atmosphere.
Okay, so Felix Baumgartner is in the atmosphere when he's looking down, so he sees the sky below him because it's the atmosphere.
I mean, I wouldn't look at it like that, yeah, but you could say it like that.
Okay, so you can have sky below you and ground below you at the same time.
Right, it's just air below you.
So not the sky.
So when you say the sky appears to be getting lower as you look towards the horizon, you're really saying the atmosphere appears to be getting lower, right?
If you want to be more technical. And we could just say molecules are getting lower, if you want to be really technical. Then atoms are just, we could get really technical. Loot.
You don't really see the molecules though.
And if you want to get technical, molecules getting lower. Just depends how nerdy you want to get it.
Sure.
But as a whole, convergence. So when that boat seems to be going down, it's actually just...
I think you need to go back to a more reasonable flirt argument and just go with we don't know what the sky is. That would be more appropriate for you, Kimo.
Oh, the sky's just water.
Yeah. No, it's just water.
I mean, if you get
the horizon,
it would be more
so
in
the
keeping
horizon
with
is-
your flirt answers if you just came up with we don't know what the sky is.
Well,
Yeah,
I've
because
always said
now the horizon for you, Kimo, now is water appearing to meet water.
Well, yeah, it's more like a gaseous, or it's more like a finely fast water.
Finally, fast water.
Yeah, it's not as dense as ocean.
Okay.
Extremely light. Why it rises. But yeah, I mean, I guess there might be other like gases, like from volcanoes and stuff. But
Or from just anything like
other than that,
CO2,
it's just water.
oxygen, nitrogen.
I mean, again, we can get detailed. You can get more specific, but as a whole, just water everywhere. That's how I understand it. But yeah, I mean, if you want to say it's gas, I don't mind arguing the point. Gas pressure. Yeah, I mean.
Yeah, well, yeah, you don't accept that there's gas pressure. Yeah.
Well, yeah, there is no gas pressure. Volcano, which force,
Oh,
which has been
that's not
experimented
true.
with. So So where does the gas pressure come from? That's a very peculiar question.
It's not a valid question if you can just observe and measure the pressure. You don't need to know where it comes from.
What are you measuring with your magic Harry Potter wand?
No,
Barometer.
other things.
Hey, presto. Read
But does the
like a psychic
does
reading.
you said that the air has temperature, right?
Oh, yeah.
Yeah. Okay. So
It's
you
colder
know the
as you go higher.
Okay. So what's the cause for the temperature?
What's the what? The force?
The cause for temperature. You need to know your causes, right?
Wow, I mean, I think if we didn't have the sun, everything would just be really cold, right?
But why does it get colder when you move towards the sun?
Why what? Doesn't it get cold, what?
Why does it get colder when you move towards the sun?
Probably because there's
when you
no.
go higher.
Because look, I think because again, I think like we're in some kind of water, and if you leave that water, yes, then you can't increase your temperature.
So when you gain altitude, there's no water anymore.
That water is now
Increased temperature. Talking about
that
decreasing
water
temperature as you
that
go
water.
higher.
Decrease. Yeah.
Well, that
Decrease.
water gets colder,
Hey,
right?
Spurs said increase.
Yeah, if you go higher, the temperature goes down, right?
Yes.
Yes. So is there less water? Or what? Because you're going towards your heat
Not less
source.
water, is it? There's snow on mountains, right?
So why does it get colder when you go towards your heat source?
Why does it get cold?
Yeah.
That's just a posh. I don't think anyone knows that.
Okay,
We
so
don't know if
you
that
can't
even
say
is
that there's
a fact. That is a fact. We don't know that.
then you can't say that there is temperature because by your logic you don't know the cause for it, so it
Well, I
doesn't
did say
exist.
the
Just like
sun. Without the sun, everything would be really cold, right?
but when you move towards the sun, it gets colder.
We don't know that, do we?
We can measure temperature, right?
Can we?
So now you're going to deny temperature too.
No,
That's a
you're
good
saying
one.
you
So
can
there's
measure to
no
the
pressure
sun.
and no temperature.
What about the sun, right?
Yeah, if I get higher, the temperature goes down, even in daytime.
Yeah.
So if the sun is your heat source, why does it get colder when you get
The sun
more
is
closer
local
to
and
it?
low, isn't it? That's why.
Well, that would mean that you'd have more temperature, higher temperature when you move towards it, right? If it's
It's hard
small
to
and
say. We
local.
don't know what. That's what we don't know what the sun is.
Yeah, so you don't know if the sun is the cause for the heat.
Well, I just assume that's where when you look at it, you put your hand out, it's like
Yes.
really warm.
So now you have no cause for your temperature, so you don't accept temperature.
I just said when you put your hand out, fry an egg when the sun is out. There's heat. Yeah. Outside, you can fry an egg on the floor.
Sure.
You ever heard of
And
that
then
before?
you can move.
Can't fry an
You can-
egg on the floor in Antarctica.
Using the sun.
Yeah. Ground cannot get hot enough.
Okay, so the sun isn't the cause for heat then.
No, because the ground would melt the snow.
Okay, so are you now saying
No,
that
the
the
sun
sun
would
isn't
melt
the
the
cause?
snow, sorry.
So there's no sun in Antarctica because it would melt the snow?
No, because the ice would freeze the egg for a start, right?
Sure, but there's the sun giving you heat, so why would it freeze?
Probably too far away, the sun.
Probably.
Probably, who knows? But we know we can fry an
So
egg
you-
in the
so you-
in the sun, right? In a hot country.
Sure,
So
you can also burn
what's the
ham.
cause of all that heat?
Yeah, I'm asking you.
Well, that's what I'm saying. Do you not understand that the sun at that time causes you to be able to cook an egg?
Yeah, but if I go towards the sun, it'll get colder.
Yeah, okay. Well, we don't know that again.
You don't know that, so you don't accept that we've measured temperature with the change with altitude.
Yes, absolutely.
So if I'm in an airplane traveling in daytime and it's 60 degrees below Celsius, 60 degrees below freezing, but I'm closer to the sun, but it's a lot colder than on the
How
ground.
close to the sun are you?
I'm 13 kilometers closer.
How do you know how far the sun is?
No, I said I'm 13 kilometers closer because I know the distance to the ground from my position.
Yeah, but how do you don't know where the sun is though, right?
I know it's above me.
So you might be looking at the apparent sun.
So is the apparent sun or the actual sun the cause for the heat?
Could be both.
So you can fry an egg with the apparent sun, right?
Could be, could do.
So the apparent sun is the cause then.
Could be. It's a possibility.
So when I get closer to the apparent sun, it gets colder.
Possibly, yes. Good one.
It does. It's not possibly, but it does.
Yes. Maybe because you've got all the water inside you. Keeps you cool.
All the water inside me when I'm inside an airplane, measuring the temperature outside the airplane.
Oh, you're inside the airplane. I thought you meant outside.
But the outside of the airplane, yes, is measuring the temperature. You don't measure your temperature inside an airplane to know the temperature outside the airplane.
Got it. So yeah, I mean, we're just trying to look at the cause and the fact. Yeah, this is how we would.
Yeah, you don't know the cause for the temperature, so I mean, you don't accept temperature then because I use the same logic for that you use for the pressure. No cause, no pressure.
We're just postulating, right? What it could, what it might be, what it isn't. Right now, nobody knows anything about this world, right?
Why don't you do the same thing with pressure that you do with temperature? That you accept that there is temperature, but you don't know the cause.
Again, with the temperature, it could be a volcano, it could be under the ground with lots of lava.
Yes.
It could be
a pressure, there could
system.
be gravity, could be X, could be Y,
many things, you know?
Yeah, and same with the atmospheric pressure.
Okay, how are you going to test it?
Could be heat, could be a lot of things.
When have you got closer to the sun and it was colder?
When have I done it? The last time when I took a flight.
Yeah, but you were inside the plane.
Yeah, measuring the temperature outside the plane.
How did you do that?
There's temperature gauges outside the airplane measuring the temperature.
So you use
the
airplane's temperature.
Huh?
You use the airplane's temperature gauge.
Yeah, or the thermometer, yeah.
What on the screen? You mean?
Yeah, that's where you get the reading, but you can also see it in the cockpit. But I wasn't in the cockpit.
Where did you see the reading?
You can see it in the IFE screen.
Okay. And what I don't see the point. So it told you the reading, and now what?
That when I get closer to the sun, it gets colder.
But you wasn't close to the sun.
I was, because I was gaining altitude and the sun was above me.
Yeah, but you were still nowhere near the sun.
Yeah, but I was closer to the sun.
No, you wasn't near the sun.
But I was closer to it.
But not near.
Yeah, but that doesn't matter. I was closer to it.
But you wasn't near to the sun.
That has nothing to do with it.
You went closer, but it doesn't mean that you were near the sun.
Sure, but I was closer to it, so I should, if the sun...
No, because you need to be near the sun.
Ah, okay. To know
or
what?
Or close to the sun. Not just moved closer.
Close to the sun.
You wasn't close to the sun, you said you moved closer.
Yeah, but in order to know what
close
do
to
I need to be close
right?
to? But what do I need to... Like, why would I need to be...
So you need to go closer. Go closer.
Yeah, and then I'd know what?
You would feel the heat.
Have you done this experiment?
No, you said you've done it, you didn't feel the heat.
But
so
you
we have to
said
be
that
close
if I
to
get
the.
close to something.
They go
to know.
close.
So we
to
have
the
to.
heat.
So we have to be close to the sun to feel the heat, do we, Chemo?
No, in this instance, he would need.
Hey, so
Why
Kimo,
would I-
Why do I feel it at the ground then?
so Kimo, why do
There's
mountains
more-
have snow?
There's more water down there.
But they're closer to the sun, Chemo.
You got the ground, even off the ground. Remember the egg?
So Kimo, why do mountains have snow but flat plains tend to not have snow?
It just depends how close the sun is.
But the mountains closer to
So
the
they're
sun.
obviously
than
closer to the sun.
No, because the sun
Yeah.
goes up and down, up and down.
Yo, what?
It rises above the mountains, does it?
Yeah, it goes up
Wait,
and down.
wait, how does it? Wait,
Bypasses
what?
the mountains.
Yeah, it moves up and that's where you get
You
hot.
just need to get over the mountains, right?
Yeah,
Somebody quote that.
something
Somebody
like
quote that, please.
like that, but not as close. to the sun.
So if it moves up and down, then when I move up and down, I should feel hotter when I get altitude, and when I come down, I should feel colder, right?
Obviously, it was too close to the mountains. It would melt them, right?
What?
It would melt the mountains like wax.
How do you know that? Because you don't know what the sun is.
No, we don't know.
Yeah. So how do you know that it'll melt a mountain?
I assume.
Okay.
We're assuming, right? Nobody knows any of this, what we're talking about for sure, for facts. Do you?
Yeah. So why do you then accept that there is such a thing as temperature?
Oh, because at night, it's cold.
I could just
How do
imagine
you
as
know
the
that?
sun's approaching a mountain. Pull up,
Pull up, pull
terrain,
up.
pull up.
Right.
But you're saying that at night it gets colder. It's like me saying that when I gain altitude, there's less atmospheric pressure and I can't breathe.
What, is it warmer at night then?
No, I didn't say anything about temperature. I just said give you a comparison.
No, you're saying that how do you know the sun causes the temperature, right?
Yeah, in your view, yeah.
If we
Why?
remove the sun, if we go where there's no sun, do we have high temperature or increased temperature?
It depends because in the nighttime,
Mm.
in let's say Spain,
Mm.
it's much hotter than in the daytime in Finland sometimes.
That's because the sun was closer and the ground preserved the heat longer.
So the sun didn't heat Finland in the daytime when there's 20 degrees Celsius, like negative 20 degrees Celsius.
No, it was higher over Finland.
So chemo,
Higher.
I'm at 36. Chemo, I'm at 36 degrees south latitude, right? And in the summer, the days are about 14 and a half hours long here. So why does the sun set for me?
We don't know what the sun is, Paul. Problem.
Oh, okay. So
And
that's
actually,
your catch-all
Paul,
answer.
There's an interesting question, Paul. Like you get like 14 hours of sun during the day.
Yeah, I
And it
know.
gets- How hot does it get there?
Oh, it gets pretty hot. It can get up to like 46 degrees Celsius.
Alright,
Yeah, and
so
over here in Finland, it's rarely over 30, and we get 24-hour sunlight.
can I,
Yeah, go figure.
can I
Yeah.
get I like a clarification. Kimo say he doesn't know what the sun is. Yeah, he claims it's hotter when you get closer, and it goes ups and down. Yeah, he doesn't know what the sun is.
Yeah, exactly.
And he accepts temperature as a thing, but doesn't accept temperature pressure because there's no cause for pressure. But he doesn't have a cause for temperature now.
Yeah, and apparently the sun like sets because it goes too far away and we can't see it. And yet, like I can see it for 14 hours during the day here in summer. So, where is it for those other 10 hours?
Yeah, and at the same time over here in Finland, while you have 14-hour days, I have like, I don't know, 6-hour days or 8-hour days. It's kind of fishy.
Yeah,
We're still learning about where we live, guys. Nobody knows.
I mean, if the sun goes too far away for me to see it, then obviously for 14 hours it must be fairly close by me in the south, right? Because I can see it for 14 hours. It must be close by. Well, if it's close by me, then how come other people in the south also get 14 hours of daylight?
Yeah, and people in the north get like over 12 hours of darkness.
We're still
And how can
learning.
it,
We're still learning.
how can it go too far away for you to see if the atmosphere acts like a magnifying lens and holds the angular size of the sun? Should always be visible.
I mean, what's the point? I would like, how do you have 24-hour darkness in the north, Chemo?
Again, these things there we're trying to figure out, and this is why we ask questions about evidence. Obviously,
Yeah, but you see, the thing is, we have figured it out. We have an explanation for it. So you trying to say that ours is wrong is not right, because you just don't seem to know what the sun is.
Yeah, nobody knows these things. This is the very point.
Yeah, well, no, you don't project now.
Yeah, but you said that you know a lot about the sun.
What is it?
You said that you know. You said that you know about it. You said.
Oh no, just assuming. Look, nobody has a map.
Yeah, you said it has to go up and down so it doesn't melt mountains, right?
We're just trying to build something. We assume. Do you not understand these words? We are presuming these things. Nobody has any idea.
But do you accept then
you ask me
that
anything about
temperature
flat Earth or stuff like that, we are assuming. Nobody's been to the dome. No one's been to
presuppositions
the
weren't allowed. I thought presuppositions weren't allowed.
Well, you're asking for them.
Yeah.
I've told you.
Okay, so do you accept temperature is a thing?
No one has been into space to see the entire Earth. Nobody knows these things. So we're all assuming.
Blah blah blah. But do you accept that temperature is a thing?
Temperature is caused by the sun, I assume.
Okay, and pressure is caused by gravity, I assume. Do you now accept pressure?
Well, we can test temperature by like we can make a freezer. We can put like a heat source in there. See if we can change the temperature of that like room.
I was actually in a position to have sound hitting my face.
And then we can
in
also
like
outside, we can make a fire outside at night and see if the temperature changes. If we can affect the area and increase, without the container, just increase the temperature outside at night.
Without a container.
Without a container, we can just make a fire. We can make a fire without a container. Without a container, we can make a fire on the floor and increase the temperature, get our devices, and then we can say, look, or we don't even have to make a device, we can just feel.
So you can feel without a container.
Without a container, we can make a fire on the floor,
okay. Yes. So there is no container there.
No, I'm saying I can take a piece of paper, light it on fire, and the temperature will increase.
Yes.
Hey, now how are you going to prove pressure? You said pressure. How are you going to increase the pressure here on the ground, like I just did with the temperature?
I can use the leaf. I can use the leaf blower.
I got hold in my farts to increase pressure.
Yeah.
Hold on. You're going to take a leaf blower?
Yeah.
Okay, go on.
Yeah, and I blow air with the leaf blower into a barometer.
Mm-hmm.
The reading goes up.
Yeah, temperature.
No. Barometers don't measure temperature.
How are you going to control for the temperature?
Why would I? How did you control for pressure when you burn paper?
I did assume pressure.
Yeah, and I don't assume temperature.
We don't need to. I can burn you with a piece of paper and you'll feel it.
Yeah, and I can blow you with a leaf blower and you will feel it.
Cold temperature is what I feel. Lower temperature. Cold air.
Yeah, but it's the same air, so it's not different temperature.
Just cold air.
No, it's the same air.
You blow air, it's going to be cold.
Why? Why would it turn colder?
I don't know why. You just lower the temperature.
So, how do you know that it's colder?
I can feel it.
So you're assuming the consequence?
No, I can feel it.
How do you know that you're feeling cold and not pressure?
I know what hot feels like.
How do you know that?
Because I felt hot. I can feel hot.
Are you presupposing that it's the movement of the air that makes you feel cold?
No, I'm saying I can feel when I'm hot and I can feel when I'm cold. When you're ill, you feel hot. And then when you...
The presupposition that it's the movement of the air that's making you feel cold.
Yeah.
No, it's not. No, what's making me feel cold is his device. Turn your device off, I don't feel cold.
So if I blow air that's the same temperature to you, you don't feel
Same
it.
temperature.
Yeah, as you.
So if I don't want a can of soda to explode from the heat, do I just put it in the freezer?
How are you gonna blow the air the same temperature?
As you are.
Yeah, how are you gonna
I
control the
can heat.
temperature?
I can take a room, and I can measure your body temperature.
Oh, in
heat
a
the
room?
at
Yeah,
the
of
same
course this works.
temperature.
We've got a container. Works, yeah.
Sure.
You're talking about out. Oh, so we live in a container outside. Welcome to Flat Earth.
Well, okay, I can take you outside somewhere where is
Mhm.
the outside temperature is the same as your body temperature.
Outside
And
temperature,
then
same as body temperature. Yeah.
Yeah, if your body temperature is 36.8 degrees, I can
Yep.
take you to Australia when there's 36.8 degrees
Yep.
and blow on you with a leaf blower.
And I feel a difference in temperature, yeah.
No, because the temperature is the same as your body.
No, but the blowing stuff, I will feel different. I will feel that.
The air is the same temperature as you.
Yeah, but I'm saying when you start blowing it, you will change the temperature.
How?
I mean, how?
Yeah, how? How did I change the temperature?
How did you change? Because you had a device. You were talking about with a machine.
So leaf blowers are designed to change temperature.
Not designed to change temperature, no.
But that's what they do. They don't blow air, they change temperature.
As a consequence of what their job, yeah.
What is their job?
A leaf blower. To blow leaves.
Yeah. Yeah? With what?
A leaf blower.
No, what is the cause for those leaves to move?
The machine.
Yeah, what is the function? What does it do?
It blows.
What?
The leaves.
So a leaf blower is a machine that's filled with leaves.
And blows your fucking da.
And you turn it on and just shoots leaves out of it.
It can do.
You got a weird leaf blower there.
It can do.
Yeah, of course it blows air out of it. So
What, hot air or cold air?
the temperature is totally relevant.
Well, that's what you're changing.
Nope.
Yep.
Nope.
Yep.
Right, that's just
Do you experience shrinkage in the cold, Chemo? Do you experience shrinkage in the cold?
Things contract in the cold, yes.
Right, okay. But then why is it that when you get a blowjob, it's the opposite? So therefore, blowing can't cause the temperature to decrease.
You didn't just say that, did you?
Debunked,
Oh
Chemo.
my gosh. Repent. Lord, forgive us. For Paul does not know what he's doing. Doesn't know what he's saying. Save him, help him. And all those
What, you're afraid of a blowjob?
Look,
Hi, I was
man.
echoed to the heavens. Lord, forgive me. There was gunshots.
Forgive him. Doesn't know what he's
Remember
doing.
that, Kimmel?
Alright, he's been led
Lord,
by
forgive me. I was echoed up to the eyeballs.
He's
Lord,
been led
forgive
by
me.
demonic entities.
How did it go again?
Okay, back to Moleman.
No, Jesus, I'm done. When you say leaf blowers blow leaves, it's
I didn't
over.
say that. You
The
said
leaf blower blowjob?
No,
No,
blow
you said it.
leaves on the ground. That's what I meant, not out of the machine.
No, that is what you actually said.
No.
We're done.
But anyway, look, the idea is, we are done because you can't demonstrate pressure. You just made up gravity and then started introducing machines, which if you want to say makes pressure, so what? Your device is the cause of that pressure. Your leaf blower. So is leaf blowing causing the pressure in the atmosphere? No, don't be silly. So the idea is change and control the heat outside of a container, without a container.
By that logic, you said that burning paper causes sun to give off heat. So
No. I'm saying that we can change the heat, change the temperatures. You can't change the pressure because you need a container. And even with your leaf blower, that is a container. So if you want to say that's pressure, fine. Still a container. Create that pressure without that container that you're holding. So, yes, the idea is...
So, Kimmel, what happens to a soda can in the freezer?
Soda can in the freezer. So all the oxygen tries to escape and that's why you get the gas tries to escape. That's why you get the effect that you get.
What effect is that?
So what? It will like expand a little bit, right?
But it's colder, isn't it?
Yeah, because that's why the gas. I said it's trying to escape.
Try to escape what exactly?
The can, the drink.
Why would it try to escape the can?
You talking about water?
I'm talking about soda.
Like a fizzy drink.
Yeah. Why does it explode in the freezer?
It's lower. It's a lower pressure, lower temperature in a freezer. Inside the container, you can lower the pressure. Yeah.
Yeah, but it still explodes.
No, because they're made strong enough to withstand that low pressure.
They explode. They explode in the freezer.
Oh, the can?
Yep.
Yeah, I just told you why.
So why does it explode in the freezer?
Because the gases are trying to escape. It's like a vacuum. They're being sucked out of the can.
Can you prove this?
You've just said it explodes.
No, can you prove the gas is trying to escape?
Oh my gosh.
Why would gas try to escape if it's cold?
Because that's what a vacuum is like. It's lower temperature, lower pressure. In a vacuum, without the ice, it gets colder. Put water inside, it can turn to ice. It's taking all the oxygen outside of the water, heating it. And the same thing in a freezer. It's lower pressure, like a vacuum, and the same things will happen.
Right. Kima, can I ask you a couple of questions?
Yeah, we haven't got long now. Go on.
Yeah, this will be relatively quick. Okay, so when you have a balloon, so you have it on the surface, okay? No, it's just sitting there. It's all fine. It's all stable.
What is that?
Music.
Who is that? What was that?
Someone was blasting music.
Who?
I don't know. I didn't see who.
Don? What was that, Don?
I saw somebody blast
was
the music
Don,
and
it's
leave
alright.
real quick.
Okay, so
Go on then.
yeah. So when this balloon rises, so let's say it's helium, okay? So when it rises into the air, eventually it pops. Why does this happen?
Why? Because the shell becomes brittle, okay, and very weak. The exterior becomes. That's why NASA have to build very strong materials to get the balloons as high as possible. But because it's so cold, it becomes brittle. Now you've got this pressure inside, because in a container you have real pressure, and the pressure inside is pressing on the brittle balloon. Yes, when of course it's going to explode, right?
Okay.
Think
So
about
it
it.
explodes
If you're
the
inside
balloon
a really tiny glass chamber, and you're pressing from the inside, pressing, and that glass on the outside becomes weaker somehow. Of course, the pressure from you is going to break the glass, right? From you pressing inside, as the outside becomes weaker. Yeah?
Mm-hmm.
You dig? So as that balloon goes into a colder environment, the rubber or whatever becomes weaker, a lot weaker, brittle, you might say.
Okay.
And like I said, because the inside pressure is still in there with the gas or whatever, trying to fill all spaces, you know, and that's what it tries to do and does it when it has an opportunity, when the gas is when the outside is weak enough. That's why it happens. Now you think, obviously, I know your answer. It's like, well, there's less pressure outside and more pressure inside, and the gas is trying to fill that lower pressure area. But no, if you were able to maintain like that balloon's like temperature, if you didn't get weaker, the balloon, it wouldn't explode.
Okay,
Why when they have strong, that's why that Phoenix Baumgartner was able to hover so long, because whatever material they used was able to keep him up there than just the normal balloons that you guys.
Okay. So how about instead of we were letting this balloon rise all the way and then pop, how about we just let it rise a little bit, and we do see.
Well, what's going on there?
I don't know who's doing that.
Don, what are you doing? Right, Don,
bugger off.
Don. Yeah, I mean,
So
pretty much it now.
We'll let this balloon rise up a little bit, not all the way till it pops. And what do we notice? We notice that it's expanded. Why did this happen?
Yeah, I've just told you why.
So, does brittle things expand or do they burst?
It gets weaker.
Okay.
Weaker. Yeah.
And this is temperature related then? The weakness of the balloon?
Added with what? The inside pressure. Oh my gosh.
Yeah, okay.
Super
so how about
stuff.
when we have a bag of crisps or chips or whatever you want to call them, and normally they're like, of course they have a little bit of gas inside, but they're not like trying to expand a bunch. But if you bring them on an airplane, what happens?
Say again. So it's really hot inside the crisp packet, yeah?
No, I said, so you have a crisp packet and there's some gas inside. You put some gas to make sure the crisps don't go stale.
So it's really hot inside, yeah?
What makes you think it's hot inside?
Inside the crisp packet.
Yeah, why do you think it's hot inside the crisp packet?
What do you mean why? More tight space.
But let's say you leave this in a room. Are you saying it's going to contain that hotness?
Of course.
Why are you breaking the second law of thermodynamics? Heat wants to escape.
What, inside?
You're breaking the second law of thermodynamics.
Oh no, it's got the crisp inside. It's got the crisp inside. It's like its own little planetarium or something.
But Kimo, you're breaking the second law of thermodynamics. The heat has to escape.
No, because there's crisps inside.
What are the crisps making the heat?
No, they're regulating the bag.
Okay, but then the bag will have that temperature,
right, I've got to go
and the
now,
outside
anyway.
of the bag.
We'll have to carry on later on. We will. Right?
Okay. Just think about how you can not violate the second law of thermodynamics.
They'll do.